Hello! In the last movie, we discussed some fundamental terminologies that you may want to check out before today's topic. Alright, we're finally here discussing a prime topic of mathematics, that is, factorization of quadratic equations. And if I do my job right, you will leave this video with a sense of satisfaction and a hype that you can solve any quadratic equation that math has to throw at you using this special technique of factorization of quadratic equations. Let's start with the word factorization. It is a process of separating or taking out a common term or a common factor. That might look like a definition, but it is just a measly sentence written by yours truly, so please don't go memorizing it. I personally believe that in order to fully understand the meaning of factorization, one should simultaneously look at its opposite process as well. This opposite process is called distribution, also referred to as expansion or expanding. In your previous math classes, you may have come across an expression like 5 and then inside brackets x plus 3, which you may have simplified as 5x plus 15. Here you have essentially multiplied both the terms inside the bracket with what is outside the bracket. We would say 5 is distributed across x and 3. But when you start at 5x plus 15 and then write it as 5 and then inside bracket x plus 3, what you have done now is factor out a 5, and that is how simple factorization is. Let's factorize another expression, 5x squared plus 15x. The first term is 5x squared, which you may want to think of as 5 times x, and the second term is 15x, which you can think of as 3 times 5 times x. By the way, those dot-like looking objects represent multiplication and are very commonly used in higher mathematics. And I'm going to use those very extensively in this video, so commit that to your memory. Okay, so what is common for both of these terms? A 5 and an x, right? So you write the common things outside the bracket and write those uncommon things inside the brackets, while also thinking about the sign between the two terms. That is what you would call factorization. And believe it or not, that in essence is all there is to factorization. These processes of factorization and distribution are found almost everywhere in mathematics. They are like the fundamentals or the building blocks. Now what we're going to do is bring these processes into a very specific topic in mathematics, which is quadratic equations. Let's start with a simple example. Find the roots of the following quadratic equation, x minus 8 times x plus 7 equals 0. Alright, the first thing you may have noticed is the word roots. It is just a fancy mathematical way of saying solution. Another fancy phrase that is often used is zeros of the equation. By the way, I have created another video where I try to explain terms like solutions of equation and substitution in a deeper sense, so consider checking that out after watching this video. Alright, that was just a side note. Moving on. X minus 8 times x plus 7 equals 0. Yes, this is a quadratic equation, albeit not in the standard form, it is still a quadratic equation. Just to make sure that all of us are on the same page, what I'm gonna do is simplify it so that it looks like a quadratic equation in general form. So here we have two binomial expressions multiplied by each other. Those things that are inside the brackets, they are each called a binomial expression. Anyway, you have to follow a pattern in order to distribute this properly. In the Western education system, they use a pattern called fall method. First, outside, inside, last. You can use that method, but what I'm about to show you is more applicable. At least I believe it is. Each term of the first bracket multiplied by the entire second bracket, which means first term of first bracket multiplied by the entire second bracket, and likewise the second term of first bracket multiplied by the entire second bracket. Therefore, we have x times x plus 7 minus 8 times x plus 7. Now once again we need to distribute, but this time it is a single term multiplied by a bracket of two terms, which is not as difficult. X times x is x squared plus 7 times x is 7x, then negative 8 times x is negative 8x, and finally negative 8 times positive 7 is negative 56. Now x squared remains as is, 7x minus 8x is negative x, and negative 56 remains as is. What this means is the initial equation x minus 8 times x plus 7 equals 0 is the same as x squared minus x minus 56 equals 0. Now that we have simplified this equation into its general form, there is no room for doubt as to whether or not it is a quadratic equation. We know it is quadratic because it fits in the general form of a quadratic equation. By the way, I've made an amazing video on that as well, which is the most viewed and the most liked video on this channel as of today. How about changing that by smashing the like button? The question says find the solution. It did not ask us to validate that the given equation is quadratic. I did that just so that all of us are on the same page. So that means all this work is just a side note and not a part of the answer. So I'm going to move this. Now we're back to the beginning. X minus 8 times x plus 7 equals 0. Whenever you have a quadratic equation in this form and you are supposed to find the roots or the solutions, what you have to do is apply a rule called the zero product principle. According to the zero product principle, if the product of two things is 0, then at least one of them is 0. This is the first thing multiplied by the second thing, and the multiplication is equal to 0. So according to this principle, either the first thing is equal to 0 or the second thing is equal to 0, which incidentally implies that both of them can also be equal to 0. And if you think logically about this principle, it will start making sense. Take a look at this. 5 times 7 is 35, 5 times 0 is 0, 0 times 7 is 0, and 0 times 0 is also 0. If the right side is 0, then at least one term on the left side is 0. So returning to the problem at hand, we have x minus 8 equal to 0, which we can simplify as x equals 8. In your mind, you may have added 8 on both the sides, then cancelled out plus and minus 8 on the left side, or you may have just moved the negative 8 from left side to the right side, knowing that such an operation changes the polarity of the number. Both the routes are equally correct, and so do what floats your boat. Alright, so here we have x plus 7 equal to 0, which can be simplified as x equals negative 7. Therefore, x equals 8 and x equals negative 7 are the two solutions, or as the question says, roots of the given quadratic equation. Also, some books refer to the zero product principle as the zero factor property, and some books choose to not call it by its name. Nobody is going to ask you what the name of this property is, so feel free to forget the name, but remember the meaning and the application. Alright, now we have to find the roots of this quadratic equation. 10x squared plus 15x plus 8x plus 12 equals 0. Here, it is very easy to verify that this is indeed a quadratic equation, right? You just have to add these two middle terms to get 23x and it will look similar to the general form of a quadratic equation. I'll move this to the next page. You may wonder why Victor chose to frame this quadratic equation in such a manner. You will understand the answer very soon. First, let me rewrite the equation as is from the question. Take a look at the first two terms, 10x squared and 15x. You can think of 10x squared as 2 times 5 times x and 15x as 3 times 5 times x. What is common? A 5 and an x, right? So we will write 5x outside and put the remaining stuff inside the bracket like so. Now look at the third and the fourth terms. 8x plus 12. You can think of 8x as 4 times 2 times x and 12 as 4 times 3. What is common? Just a 4, right? So we can write 4 outside the brackets like so and the remaining stuff inside the brackets like so. And don't forget to write the right hand side equal to 0. Now notice that we had 4 terms in the previous step and now we're down to just 2 terms. Terms are usually separated by positives or negative signs. Now take a closer look at these 2 terms. This is the first term and this is the second term. What do they have in common? The brackets and the stuff inside is the same, right? So we can factor that out and write it like so. The not common stuff was placed in a second bracket. That is how you factorize such an expression. Now it looks like the last problem that we solved, right? Now we can use the zero product principle and write 2x plus 3 equals 0 or 5x plus 4 equals 0. Positive 3 goes on the other side, becomes negative 3, and then you divide by 2 to get x equals negative 3 over 2. Likewise, this side simplifies to x equals negative 4 over 5. And these are the two solutions of the given quadratic equation. Before moving forward, let's reflect on this problem. This quadratic equation was framed in a slightly different fashion than the general form, right? The middle term, or the x term, was split in two terms. You may already know the reason why, but let me put this out there. The factorization that we did was possible only because the x term was split into two terms. That does not mean you can split it in any random combination. Sure, writing 23x as 10x plus 13x is equally correct, but you will not be able to factorize it. If you don't believe me, then go ahead and try to factorize it. You will not get to the final solutions. I want to emphasize the fact that writing 10x plus 13x is mathematically correct, but it is of no use because we will not be able to factorize the equation. You can write 23x in so many different ways, right? 24x minus x, 20x plus 3x, and the list goes on, but only one combination will factorize and lead to the final answer. In this case, the combination was 15x plus 8x. Again, I want to emphasize that only one combination can lead to the final answer, and that is what we are going to focus on from this point until the end of the video. How to find that combination, or how to split the middle term properly. The first thing that I want you to know is that usually the quadratic equation given to you will be in the general form or very close to the general form, something like this. In the next step, you are supposed to split the middle term properly. Remember, only one combination works for each quadratic equation. This step over here is something that most people don't do because factoring out a common term is considered a simple and intuitive step. Then, in the next step, you factorize twice. After that, there is another step where you factorize, but this time only once. In the next step, you apply the zero product principle, and after that, you simplify to reach the final step, which looks like variable equals something or variable equals another thing. That was the gist of solving quadratic equation by factorization. Notice that while we call this method the method of factorization, the two steps where we factorize are not even the difficult ones. The most difficult step in such problems is the step where you split the middle term, and it is difficult because you have to run multiple trials and decide which combination is the correct one. Now let's consider another quadratic equation. This time the quadratic equation is in the general form. 3x squared minus x minus 10 equals 0, and this is a type that you will find on your tests. From this point on, the things that we discuss are not going to be as straightforward as they have been up until now. So, declutter your mind, drink some water if you want, maybe stretch your muscles, and give me your undivided attention. So we have this quadratic equation in general form, and the main aim is to reach the next step, which I have started calling the splitting step. We don't want to write any combination like 2x minus 3x because even though it is mathematically valid, it is useless because it will not factorize. So what I'm going to do next is write down the value of c times a here on the side. C is negative 10 and a is positive 3. Negative 10 times positive 3 is negative 30. Now below that I'm going to write the value of b, which is negative 1. Now those two numbers that we are looking for, they have to satisfy some conditions to ensure that they will factorize properly. Here are the conditions. Listen carefully. The multiplication of those two numbers should give negative 30 and the addition should give negative 1. I know that may have confused you a bit, so what I'm going to do is give names to those numbers. Let's start calling them p and q. So you want to find two numbers p and q such that p times q is equal to negative 30 and p plus q is equal to negative 1. Now you may be very intuitive and probably be able to find those numbers right off the bat, but since I want to ensure that everyone watching this video is able to solve quadratic equation by factorization, what I have done is I have created this wonderful table. As you can see, this table has a bunch of positive and negative signs in it. Trust me, it is not any random gibberish. In fact, it is going to help us find those numbers. What this table says is give me the first two signs and I will give you the signs of p and q. In this quadratic equation, c times a is negative and b is also negative. So we need to look at the fourth column of this table. And according to the table, p is negative and q is positive. Now that we know the correct signs, we can focus on finding the numbers without worrying about the signs. So for a minute now, I want you to overlook these signs. Now what we want to do is find two numbers which upon multiplication give 30. There are many possibilities like 60 times 1/2 or 100 times 0.3, but we don't want to start with those crazy combinations, okay? Start with something that is very obvious like 3 times 10. That would be one of my first guesses. So let's write that down. But while writing, write the bigger number first, so 10 goes first and then goes 3. Now let's bring back those signs. Now see if p equals -10 and q equals +3 satisfy the given conditions. -10 times +3 equals -30, so the first condition is satisfied. Let's check the second one. -10 plus +3 is -7. So this combination of p and q is not correct because it did not satisfy the second condition. Remember, both the conditions must be satisfied. Now, again, overlook the signs and try a different pair of numbers that upon multiplication gives 30. The next number 4 does not go into 30. Then the next number 5 goes into 30, right? 5 times 6 is 30. So that is our next trial and we can write it down. Again, while writing, write the bigger number first, so 6 goes first and then goes 5. Now uncover the signs and check if both the conditions are satisfied by p equals -6 and q equals +5. -6 times +5 is -30, so the first condition is met. Now the second one, -6 plus +5 equals -1. Even the second condition is met. So this combination is the correct one. The difficult part is over and you can take a breather. If you're curious, try finding another set that satisfies both of these conditions. I assure you that no other combination will. Anyway, we have accomplished the main aim of finding the proper combination. Let's write it. Now the next step is to factorize. But before moving to the next step, make a habit of quickly comparing these two terms and the middle term from the previous step. If they are not equal, then you have made a mistake. Okay, now let's factorize. Here 3x is common, so we factor it out and write x minus 2 inside brackets. And here 5 is common, so we factor it out. And this is what we are left with. We know that the next step is again factorization. And for that, these two brackets should be the same. So if they are not equal, then you are not on the right path. Okay, so we can factor out x minus 2 and 3x plus 5 goes into the second set of brackets. Now we can apply the zero product principle. X minus 2 equals 0 or 3x plus 5 equals 0. Simplify to get x equals 2 or x equals -5/3. One of the questions that learners tend to have is about the order in which you write these terms. Don't worry about the order in which you write these. You know what? I'm gonna demonstrate it to you right here and now. 3x squared plus 5x minus 6x minus 10 equals 0. First two terms are 3x squared plus 5x. The only thing that is common is x. So, x and then inside brackets we have 3x plus 5. Remember, the first two terms will always have a common factor of x. There could be more in common, but 1x is always common. Now, the third and the fourth terms are -6x minus 10. -6x can be thought of as -3 times 2 times x and -10 can be thought of as -2 times 5. You may say that the common thing is 2, but you're forgetting the negative. It is also common. So we factor out -2 and put the remaining stuff 3x plus 5 inside brackets. The next step is to factorize again. Look at both the brackets, they are the same, so factor them out and put the remaining stuff inside the second set of brackets. Apply the zero product principle and you get 3x plus 5 equals 0 or x minus 2 equals 0. Simplify to get x equals -5/3 or x equals 2. So don't worry about the order, they lead to the same final answer. In fact, they start looking the same right at this step. Also, while writing this down, another common question popped into my mind. What if I forget to factor out the negative here? Don't worry, let's redo this. But this time let's forget to factor out the negative. The third and the fourth terms are -6x minus 10. Let's factor out a +2. So inside the brackets we have -3x minus 5. The next step is again factorization, but before that check to see if these brackets are equal. Oh no, they are not. But look carefully, they are only different in signs. This bracket on right is equal to the left one multiplied by -1. So in the next step, factor out a -1. Now they are equal, right? So you're good to proceed. So be sure to really do this step instead of just copying the bracket as is from the left side. A cool trick that you can remember is that you always write the sign of the third term outside. Since our third term was -6, you should ideally factor out the negative as well. Another thing is that x will never factor out from the third and the fourth terms. Wow, that was a lot of information, and I still think there is so much more that I'd like to share with you, but I simply cannot because I don't want to risk overloading you. For now, remember that the process that we just followed may seem to be very long, but once you sit down and solve like 10 to 15 quadratic equations with this method, it will become a part of your muscle memory. Most people can solve quadratic equations in less than a minute, and trust me, you too will very soon be able to do the same. And as for the table, I have attached a link in the video description. It is a PDF file that I have created and it contains the table. Feel free to download it and maybe print it. My instructor had given this table to me when I was in school and I memorized it. This is the method that I used to solve quadratic equations even when I was in college. That is how powerful this method really is. If you want to memorize the table, don't do it horizontally. Do it vertically. Plus plus, plus plus, plus minus, minus minus, minus plus, plus minus, minus minus, minus plus. And seriously, that is how I memorized it. The Western education system typically allows students to carry note cards, so you don't have to memorize it if your instructor allows it. Just write it down on a note card. As for the other education systems that don't allow note cards, like my home country India, याद कर लो दोस्तों, कोई और option नहीं है. I'm planning to attach another PDF file with some quadratic equations for you to solve, so do check that out. At this point, I would have ended the video, but I reconsidered my decision and I'm about to solve another quadratic equation. The numbers are going to be different, but the structure will remain the same. So if you want to stop watching, then be assured that you will not miss out on anything. But if you don't have anything better to do, then stay, because it will help reinforce the concepts that you just learned. The quadratic equation that we are now solving is 10x squared plus 3x minus 4 equals 0. C times A is -4 times 10, which equals -40. B equals +3. The conditions that the two numbers must satisfy are P times Q should be equal to -40 and P plus Q should be equal to +3. Now use the table to write the signs of P and Q. Minus, plus, plus, minus. Therefore P is positive and Q is negative. Now cover the signs and find two numbers that upon multiplication give 40. Let's start in an ascending order. The first guess is 2 times 20. Let's write it down. Remember to write the bigger number first. So 20 goes first, then goes 2. Now uncover the signs, check if this pair satisfies the given conditions. You will notice that it does not satisfy the second condition. +20 plus -2 is +18. So this combination is not correct. After 2 we can try 3, but it does not go into 40. So moving on. 4. 4 times 10 is 40. Let's write it down. Remember to write the bigger number first, so 10 goes first, then goes 4. Now uncover the signs. Check if it satisfies the conditions. You will notice that it does not satisfy the second condition. +10 plus -4 is +6. So this combination is also incorrect. After 4 comes 5 and 5 times 8 is 40. Bigger number goes first, so 8 goes first, then goes 5. Uncover the signs. Now check the conditions. You will notice that both the conditions are satisfied. So we can write the splitting step. 10x squared plus 8x minus 5x minus 4 equals 0. Now from the first two terms factor out 2x and you have 5x plus 4 inside brackets. Then from the third and fourth terms all you can factor out is a -1 and inside brackets you have 5x plus 4. The next step is again factorization. Check if the two brackets are equal. They are, so we can proceed. 5x plus 4 can be factored out and we put 2x minus 1 in the second set of brackets. Now apply the zero product principle and you get 5x plus 4 equals 0 or 2x minus 1 equals 0. Simplify and you get x equals -4/5 or x equals 1/2. Alright, those are the roots of the given quadratic equation. I believe I gave my best attempt at explaining this topic completely. So please consider sparing a moment to give this video a thumbs up or a thumbs down, to write a comment about your views on this video. If you have any suggestions, feel free to use the comment section, and as always, thank you for watching.